And hello everyone, welcome back. The last video we were talking about SnappyHack Mesh, and we saw that the mesh size was so big that it caused the whole computer to start lagging. So in this video, we actually, I just did some back work. Alright, just did some editing to the system file, and specifically SnappyHack Mesh ticked. And what did I do? Well, for one, I tried to control the refinement so that the surface refinement is reduced by one level. So instead of a level 3, it becomes a level 2 now. However, there are two regions that I want to refine more finely, which is what I call a top patch box and a bottom patch box. So what are these top and bottom patch box? You take a look at the surface. Okay, I'm going to put an internal patch there. Alright. So usually the places which matter are the places where the cylinder is starting to curve and there's this sharp angle here. So I drew an imaginary box around them and told OpenFOAM, hey, I want to refine it to a level 3 in this box. So everywhere else is a level 2 refinement, and in this box it is a level 3 refinement. Now what are the coordinates of this box? Now the coordinates are as follows. Is -1, -1, and -1 for the top bottom patch, and it goes all the way up to 1, 1, and 0.4. So from z equals to -1 to 0.4, we refine up to level 3. So that's the bottom patch. So let's see where the bottom patch is. So the bottom patch will be somewhere here at this part. So I draw a box around that part and I say, yep, I want to refine it more finely. Likewise, in the top patch, I also drew another box there. So I call it the top patch box. It goes from 39.6 up to 41, and that will refine this part over here more finely. So if you look at the surface with edges, you can see that you can see where this where it's starting to differentiate. Can you see? I'll use the magnifying glass. Okay. Yeah, you see where the refinement starts to be changing. So over here it's very much more fine than say the mesh here. As a result, there is some savings with respect to like CPU power in trying to process this thing. Okay, so yeah, I'm just gonna delete that. And after running, alright, after running, we find that look at the SnappyHack Mesh log. Okay, so the meshing is done in just under 2 minutes, which saves us a lot of time as well, and that's always good news when it comes to simulation. Alright, so we have created the patch that we want, and we can take a look at this internal field, same boundary conditions, no change, and then we go and see the control dictionary. Alright, so we find that this delta t, okay, of 0.005, yeah, that works. Instead of a right interval of 20, we want a right interval of 1 this time, so that we can see the evolution of the flow profile at every time step. So I'm gonna just stop changing the thing. Let's check, let's update this on GitHub. So I'm gonna put git add, git commit m coarser mesh for computation time reason. Okay, so after that I'm gonna do a git push. Alright, git push origin master. So it's gonna upload. And now that it's on GitHub, just wanted to check see if the thing is okay. You can run check mesh. So this is just a utility to see whether the mesh is okay. So the mesh is okay, that's fine. Next thing we want to run is icoFoam. Okay, so we're going to run icoFoam, and you see that the time used to solve it should be a lot faster since the mesh is coarser. Yeah. So as usual, gonna relax, fast forward, let the thing solve. So it takes about, instead of 1 minute per time step, it takes about 22 seconds, which is much better, much better. So gonna pause. No, fast forward the thing. I'm gonna fast forward. And now a few minutes in, we see that the current number again is starting to blow up. So I mean, it looks like hey, we may need to check the glyphs. We need to see the velocity vectors to see what's going on, which areas are problematic, and what can we do about them. Yeah, because this current number should not be that high at all. So probably something is wrong. So we'll be taking a look after perhaps this simulation crashes or blows up, so we can do proper debugging. And alright, so we have fast forwarded, and then again the simulation has blown up. Okay, so at least we find it out much earlier, about 10 minutes ish in. Now let's look at what snappypipe.foam looks like. And now it will have lots more data to look from. Alright, the pressure profile looks decently correct. There should be a low pressure at one side of the pipe and a high pressure at the other side. And this is the velocity profile. Okay, looks rather okay. Then we want to look at yeah, and the thing is that, as we note, it's not as laggy this time. Yep, the computer is very smooth. Let's use a slice filter. Okay, we'll apply the slice filter, and we'll look at the velocity, or rather, even better, we can do glyphs. So apply the glyph filter to see where the velocity arrows are. So apply. Okay. See whether we can. Okay. Hopefully it doesn't lag this time. Okay, that's way too many arrows. It's gonna lag for a while. Okay. Maybe I'll just do a scaling of 900 and apply. And we can see, okay, good. This is what the velocity profile should look like. Now I'll turn this off. Yeah, 900 looks comfortable. And then we can turn on the axis grid, and that will tell us where it is. So okay, flow is coming from this side towards this side, so the pressure should drop along the way. That is to be expected. So let's go. Let's press the play button and then see what happens. and then I'm gonna pause that. It's gonna turn on the slice filter. Maybe it's easier to see. New magnitude. Okay, let's play that. So there should be one part that the thing is actually blowing up. We notice this part is turning very blue. There's some velocity slowdown. Okay. So let's take a look at the slice. Perhaps we can observe the end part. Okay. Let's see. So you can see a very much red part coming here towards the end, and the simulation is starting to blow. So you can see this blue bit here. And then let's play to see what's happening. And let's go to the next time to see where this distortion is happening. Now this whole thing has blown up, so 25 seconds not really worth looking at. So something is starting to happen at the ends. Okay, something is starting to happen at the ends, and this is the output, because you see the Z axis is 40. So at least for now we have debugged, done part of the debugging, see where this simulation is starting to go wrong, and then we find that towards the end, okay, towards the end there's some problem. And let's see the direction of this anomaly. So instead of magnitude, I'm just going to go UX. UX is uniform throughout. UI is also like uniform throughout. Okay, so nothing too different with Y, nothing too different with X. Okay, it's as minuscule compared to the magnitude. Okay, minuscule. But what about UZ? Let's take a look. So something is starting to happen at the end. So in the next video, you'll look into this in more detail. Thanks for watching. I'll see you guys next time.